Alright, so this is what I call part 2 of my standalone reverb tank project. So just for context, this really started back when I was modifying this amplifier. This is a Trainer YGA1. It did not have a reverb effect built into it. It's kind of a clean amp, it doesn't even really distort much. I've kind of made it as a project where I've lovingly taken it apart and restored it and rewired it, put in new parts. I tried to keep the design as original as possible, but at the same time, I wanted to enhance it so it sounds the way that I want it to sound, which oddly enough is having reverb in it. Because this was a tube amplifier, it made sense at the time just to use tubes as the reverb driver. Now I basically found a circuit to use 3 different tubes, like a 12AT7, a 12AX7, and an EL84. And this is the reverb tank I ended up using, which is small enough to fit inside my amp chassis when it's together. Here's a close-up of the tank I ended up using. Now, the reason why I have a spare tank to make a standalone reverb tank, which is this video, is because in my conquest of finding parts, I was affected by 2 different things. One, I just ordered parts online not knowing any better because it's new to me. I mean, I just thought reverb tanks are all the same. But it turns out there's short tanks and there's longer tanks. And the first tank I ordered happened to be a longer tank. It's physically longer. And the geometry of the tank, it just doesn't fit inside my amp chassis anyway. So I ended up finding a second tank that's the same, I guess, input impedance and same output impedance, same number of springs, but physically it's just shorter in length, and this one does fit. So then having a spare tank, I wanted to just build it into a standalone effect that I could use in a studio setting that's not built in or specific into an amplifier. Generally what a reverb effect is, it's basically you take your audio input, which could be anything, and then you run it through an amplifier. The amplifier drives the transducer inside the reverb tank. Now from the point of view of the amplifier, this just looks like a speaker. The tank I use has an 8 ohm impedance coil. The second part of the reverb effect is the recovery. In this case, it's just another amplifier. So all we have to do is make that loud enough so that we can hear it. Now typically reverb units have a third component, which is kind of like a mixer. All this does is it lets us mix dry signal coming in and then the wet signal, which is the output from the spring reverb, and this goes to an output that we can blend. I decided I didn't want to build this mixer part. I'm just going to have 2 amplifiers. I started building this last November, but then I kind of found a circuit and copied it and didn't really know what I was doing, so then it didn't work. So I ripped it apart. The first step I did is just take off as much components as I can from the old circuit board. I can reuse all of these connectors, and of course the screws and capacitors are still good. My first step is to make a power supply. Because I'm using op amps in my design, as we'll see in the next schematic, I want to have plus and minus 15 volts DC. I don't need very much current, but I want to have a nice regulated DC output. Before, most of my efforts on this circuit board were to make a nice differential power supply from an AC input. I have a nice small transformer and filter caps, and there's regulators on the other side of the circuit board. But for this time, I decided I'm just going to go with one of these little modules. It's a single component that has AC in and then DC voltage out. So all I have to do is just wire it onto a board with some connectors, and then it basically works. This is the schematic for the Reverb Driver, which is actually the same schematic for my desktop audio amp that I made last month. It's just an op amp that drives a couple transistors to give it a slight bit more current capacity. I power it with differential power, which we get from our power supply. And then I feed the output. Instead of going to a speaker, I just drive it into the input of the spring tank. So same idea, placing components on a small punch board. Once again, I use surface mount components because that's just what I have, but I mount them on these little carrier boards that I made before. So this simplifies using them on these pad per hole punch boards for prototyping, because all I can do is just wire up between the pins of like a dip footprint instead of having to deal with those small 06, 03 footprints. And that's the driver board already hooked up. I have the audio input on this shielded cable here, and then power supply feeding it, and then it sends the output to a connector. At this time, the spring tank is in its own metal chassis. It comes in the module that it came in. I was just leaving it as it was and hooking it up with cables. This is the schematic for the recovery circuit. This is mostly the same circuit as the boost circuit I put in my guitars. It's just an op amp with a lot of gain and selectivity. We just basically listen to the transducer on the reverb tank as if it was a pickup from a guitar. And the output we get is, for the most part, line level output. So this can go straight back into my audio interface. Again, I used the carrier boards for helping convert surface mount parts that I happen to have into little modules, so that it makes it really easy to lay it on a board, add some connectors, and then wire up. This is actually that 30 gauge wire wrap wire. I find it works really well for doing point-to-point circuit. And here's all three modules: power supply, generator, and then recovery unit. This is the chassis I had from before. Now here, I took the spring tank out of the tank. This is just the element. So there's actually, it's hard to see here, but there's actually 4 springs that are attaching to little holes I drilled on the sides, so that this little carrier sled in the middle is just floating on its own springs. That's the transducer that generates the spring movement. It's powered by the driver. And then this side on the right is the other transducer that receives the movement from the springs. So that's like the pickup, which goes into the recovery unit. And I just have jacks on the back for the input and the output. And here's the spring unit all the way together. So I think all I have to do now is just use it. Let me go make some samples. So now to test the reverb tank, what I did here, this is an existing project I just did recently. Here I used a plug-in of reverb, which just comes with my DAW, and it has an impulse response for some kind of reverb. And what I do is, each channel, like an acoustic guitar, I have it so that it sends the signal to the reverb bus, which is this channel here. Okay, so before I add the reverb tank, let's just listen. This is what the plug-in sounds like, because the plug-in's still on. Okay, there's the plug-in. So let's turn off the plug-in. So now I shouldn't hear any reverb. Good, I don't. There's a plug-in for insert. And what this does is it lets you have an output and an input. So as an insert to this track, the audio will be sent out to my external reverb tank and come back in, and it has the same sort of experience as the reverb plugin had before. So let's just listen to how this sounds. Nice. Well, that's all I have for now. I think my next step is I'm going to rack this into my effects rack and just learn how to use it. I have to like fiddle with the knobs to get the balances and the volumes just right. And then I can either go back and play with existing things I've already written or use it for the next time I have something to make. Hope you enjoyed the video. Thanks for watching.